In this training, we will explore various welding methods, the underlying theories in this field, and how to simulate them in Abaqus CAE. To achieve this, we have utilized the DFLUX subroutine and provided a detailed explanation of how to implement it for relevant problems. To enhance understanding, we have modeled several workshops in Abaqus, allowing you to observe how to simulate different types of welds using Abaqus capabilities to effectively address your challenges. Let's explore what is included in the training.
First, we are going to introduce the welding methods, fusion and non-fusion methods, and how these methods are performed, and introduce all methods at a glance. In the second chapter, we will introduce the different elements that we are going to use in the welding simulation. Finally, in the last chapter, we will explain the different methods to apply these theories in the software. Here you will learn several ways to simulate welding in Abaqus. Also, all related details will be explained completely. After all these explanations, you will have some workshops to practice the methods you have learned.
This training includes 6 workshops, each covering the simulation of various welding methods in Abaqus. In the following sections, we provide a brief explanation of each. Now let's begin with the first workshop.
In this workshop, we are going to simulate friction stir welding process, or FSW, using the Eulerian element. We can see the results by clicking on the Results button.
But what about the second workshop? What topics does it cover?
In this workshop, we are going to simulate explosive welding. Johnson-Cook plasticity parameters are specified. You can observe the stress and strain results. Click on the Animate tool to see the animation of the whole process.
What do you think we covered in the third workshop?
In this workshop, we will explain the simulation of friction stir welding (FSW) with smoothed particle hydrodynamics (SPH) method. The USUP equation of state determines the pressure in a shock compressed solid. You see how the particle's status and stresses change when the tool moves, and they aren't thrown out of the workpiece zone.
And now, let's explore Workshop 4.
In this workshop, we will explain the simulation of butt welding with the death and birth of an element method. We have 2 materials in the simulation, base metal and weld. Now click on the Animate tool. As you see, the first step is passed. The EL1 step is running and the first weld element appears. The other steps are running respectively, and the weld elements will appear gradually. Considering that our analysis is transient, some contours like stress and temperature will change during solution steps.
This was a brief overview of Workshop 4, and more details can be found in the following videos in the playlist, as well as in the suggested package. Now, let's explore Workshop 5.
In this workshop, we are going to simulate welding on 2 cylindrical parts. The laser moves peripherally at the junction of 2 semi-cylindrical pieces. In addition to temperature analysis, our goal in this workshop is a stress analysis. Hence, the temperature-dependent material properties will be defined in the property module. The step is coupled, and we use the implicit solver. Now we explain how to write a subroutine for this workshop. Finally, we have created and submitted a job, and here its result is available.
Finally, in Workshop 6, the last workshop, we discussed the simulation of a 2-pass weld in Abaqus and how to use the provided model for multi-pass welds. This workshop is accompanied by a PDF file that will help you acquire the necessary information on how to model in Abaqus and write subroutines for it. These were the details of the topics covered in this training. which we aimed to summarize concisely. It is worth mentioning that this video playlist is part of an educational package available on our website. If you're interested, you can access the full version of the package videos, approximately 3.5 hours long, along with all Abaqus modeling files, subroutines, and the training PDF through the link in the description. Additionally, some of the Abaqus files related to this video playlist are available for free on our GitHub page, which can be accessed via the link provided in the description.